This will be for the Khan Academy exercise, scalar multiplication. Okay, it says vector v has magnitude of 3 units and it creates an angle of 160 degrees with the positive x-axis. Find the magnitude and direction of 5 times vector v. So right here in this box, we can see that this has the double bars on either side. So right here they are asking for the magnitude. So here we are basically disregarding the direction of the vector. Okay, and it says vector v has a magnitude of 3. So we want to find the magnitude of 5 times v. So it's very simple. The magnitude of 5 times v is just going to be 5 times the initial magnitude of 3. So of course that's just 15. Let's click inside the box, and that's your first answer. Okay, now we have a follow-up question. It says that the vector creates an angle of 160 degrees with the positive x-axis, and they want to know the angle for 5 times vector v. So let's draw that out real quick. I'm going to draw the vector with an angle of 160 degrees from the positive x-axis. So if I start at the positive x-axis and rotate 160 degrees this way, this is 90, this is 180, so the vector would be about right there. Okay, so starting at the x-axis, that would be 160 degrees. Now, let's say this was the initial vector v. If you multiply it by 5, does that change its direction at all? No, it doesn't. Okay, if you multiplied that vector by 5, it would just become 5 times as long. Okay, but the angle would still be 160 degrees. So in the box, you would just write 160 because nothing changed. All right, if it happened to be negative 5, then the vector would be in the exact opposite direction. It would be going that way, and you would have to add 180 more degrees in that direction. So if it were negative 5, it would have been 160 plus 180, and that's 340 degrees. Okay, so if the scalar multiple is negative, you would have to add or subtract 180 degrees depending on where you are on the graph. Okay, remember they said they want their answer between 0 and 360. But in this case, nothing changed, so it remains at 160. Okay, it says vector v is graphed in the interactive graph below. Assuming negative 2 times v starts at the origin, plot its endpoint. So here is vector v, okay, and we're looking to plot the endpoint for negative 2 times vector v. So what this means is that we have to multiply the x and y components by negative 2. Okay, and then we can plot negative 2 times vector v. Okay, so let's do that. So we can get the components of vector v from the graph. Okay, here's vector v. The x coordinate is positive 3. and the y coordinate is positive 2. Okay, so negative 2 times vector v is going to be negative 2 times 3 comma 2. Okay, it's basically like the distributive property. The negative 2 gets multiplied by the x and the y coordinate. Okay, it's very similar to distributive property. So negative 2 times 3 is going to be a negative 6, and negative 2 times 2 is going to be a negative 4. So here are the components for negative 2v. Okay, so they say assuming it starts at the origin, plot its endpoint. They really shouldn't have worded it that way. They should have said the terminal point, okay, because the endpoint is supposed to be where it starts. But I know that's not what they meant. They meant to say plot its terminal point. In other words, where the arrowhead is. So here we have negative 6, negative 4. We take our dot. We go negative 6 on the x-axis. Just click and hold it down and drag it. And then we go negative 4 on the y. 1, 2, 3, 4. Okay, negative 6 and negative 4. I hope that's what they meant by endpoint. Let's see. Okay, so really, they should have said terminal point. Okay, because the endpoint is supposed to be where it starts. And this is actually the terminal point. So notice it's in the exact opposite direction because it's negative, and it's 2 times as long because it's times negative 2. So there you go. Okay, here they give us the components of vector w, negative 25 comma 10. They want us to find negative 1/5 of w. Alright, so it's very simple. It's very similar to distributive property. You take the negative 1/5 and you multiply it by each component. Alright, so negative 1/5 times negative 25 is going to be positive 5. And negative 1/5 times 10 is going to be negative 2. So notice we just divided both terms by negative 5. Same thing as multiplying by negative 1/5. Alright, click in the box, positive 5, hit tab, negative 2. Okay, it says vector v starts at the origin and ends at point E in the drawing below. So it starts at the origin and goes to point E. Assuming negative 5v starts at the origin, which option could be its endpoint? Alright, let's see. So it says it starts at the origin and goes to point E. Alright, so negative 5 times vector v. Okay, this is vector v right here. Negative 5 vector v. The negative means that it's going in the opposite direction. And the 5 means that it's going to be 5 times as long. Okay, 5 times the magnitude. Alright, so let's see. So the vector we're looking for has to be going this way. Alright, Now, which point would be 5 times this one? Well, this is approximately, on my screen, it's about 1 inch. So if I went this way, I'd have to go about 5 inches. So that would have to be point A. All right. If I only went to point C, that's less than vector V. And if I only went to point B, that's about the same as vector V. We need to go 5 times as far. So it'd be all the way out here to point A. Okay, and the negative makes it go in the opposite direction.